Rainbows are such beautiful phenomena, aren't they? Up there in the sky, you see an arch of 7 colors, each band as pretty and mesmerizing as the next. Rainbows are quite rare since you need to have a sunny and a rainy day at the same time. In this video, let us learn the science behind the formation of rainbow. A rainbow basically needs two things: water droplets and sunlight. Under the right condition, each water droplet acts like a prism, and these water droplets disperse the sunlight into the atmosphere, creating a beautiful spectrum of 7 colors in the sky. Before learning the details of rainbow formation, we need to understand a basic phenomenon that occurs inside the water droplet, that is, total internal reflection. We know that refraction is the bending of light as it passes from one transparent medium into another medium. Here, you have two mediums, water and air. A light source is kept inside water, and the light ray is traveling from the optically denser medium to the rarer medium. As you see here, the light ray is incident normally to the interface of water and air. Since the light ray is incident normally, it does not refract and it passes straight through the same path. Now another light ray is incident, and at the interface, when it enters to an optically rarer medium, it moves away from the normal. Similar phenomenon occur for the next light rays also. If you observe, the amount of refraction is increasing as the angle of incidence is increasing. Now if you see, for this particular incident ray, the refracted ray is traveling through the interface or through the boundary of the two medium, air and water. This angle of incidence is known as critical angle. Now, if any incident light ray is incident from an optically denser medium to an optically rarer medium at the interface greater than the critical angle, then instead of refracting or instead of moving into the next medium, the ray gets completely reflected into the same medium. This phenomenon is known as total internal reflection. So the two conditions for a ray to get totally internally reflected is: 1. The light ray should travel from a more optically denser medium to a less optically denser medium, or the light ray should travel from an optically denser medium to an optically rarer medium. The second condition is the incident ray should be incident at an angle greater than the critical angle of the optically denser medium. So I hope that you have understood what total internal reflection means. Now let's look how a rainbow is formed when sunlight passes through the raindrops. When the sun's light rays enter into the raindrop, it is actually entering from an optically rarer medium to an optically denser medium. So it moves towards the normal. So at the first interface of water and air, refraction of the light rays take place. Now since these raindrops act as small prism, along with refraction, the light rays get dispersed into 7 colors, where red is formed at the top part of the spectrum and violet at the bottom part of the spectrum due to its shorter wavelength and less speed. Now, in case if these light rays are incident at the second phase at an angle greater than the critical angle of the water droplet, then they get totally internally reflected and they get again refracted from the third interface. As the different colored light rays leave the raindrop, it reaches to our eye as a beautiful rainbow. We have already learnt that different colors of white light have different speed in different mediums. So the amount of light bends as it passes through the droplet depend on the light's wavelength and color. Red light having maximum speed bends the least, and violet, which has the minimum speed, bends the most. So let's sum up. The three phenomena involved in the formation of rainbow are refraction of the light rays, dispersion of white light into 7 colors, and total internal reflection of the light inside the water droplet. And rainbows can be seen in a direction opposite to the sun. Do you know, the rainbow is not actually shaped like a semicircle or an arc. In fact, rainbow is a circle, but we can't see the full shape because the horizon cuts off the lower half. However, if you were flying high enough without any disturbance, then you would be able to see the full rainbow. The appearance of a rainbow all depends on where you stand. If you move, then the rainbow moves. For every single person, the view will be different. For you to view a rainbow properly, you have to be standing with the sun behind you and it must be low in the sky. Hope you all understood the concept of the formation of rainbow. Thank you for watching the video. Like, share and drop your doubts as comments in the comment section. Subscribe the channel for more contents of Science 8, 9 and 10th.